Today we're talking about matrix multiplication, and to multiply matrices you have to have the rows in column A equal to the rows in column B. So here we have a matrix with two, oops, if I have the pen, we have two rows. That was not working. We have two rows in this first matrix A, and then we have, it's a 2 by 3 matrix, and then this second matrix is a 3 by 3 matrix. So these two numbers, as we talked about on Friday, very, very briefly, they have to be equal for us to be able to multiply. So since they are equal, we're allowed to multiply them together. Now this is where it becomes fun. And I know you always tell me that my version of fun is different than your version of fun. So just bear with me. We'll get through this. So you are going to take, let's find a highlighter. You're going to take this first number here, this 2, we'll just do this. That 2, and that 3, and that 1, that whole row right there, and you're going to multiply it by this first column. So how you do that is, oops, if I change my things, it's annoying. All right, so how you do that, so 2 times 3 is 6, and then you have 3 times 1 is 3, and then you have 1 times 2 is 2. So that is what you will do for your first element in your thing, your matrix. Oops, if I use the right words. And then you're going to take this row, you're going to take the first row and multiply it by the second column. So if we wanted to do that to find the second element, so you're going to do 2 times 4 is 8, and then 3 times 1 is 3, and then 1 times 1 is 1. We'll deal with that later. And then we have 2 to find the third thing over here. You're going to do 2 times 5 is 10, and 3 times 4 is 12, and then 1 times 4 is just 4. So it's a little bit more complicated than what we did, but it's not terribly complicated. Just takes a little bit more thinking. So now that we have the first row done, we're going to move to the second row. So we have 2, -7, and 4. We're going to do the same thing. We're going to take this row and multiply it by the first column, the second column, and the third column. So to do the first column, we have 2 times 3 is 6. -7 times 1 is -7. And then we have 4 times 2 is 8. All right, now we're going to take the second one, second column. So 2 times 4 is 8. -7 times 1 is -7. And 4 times 1 is 4. And then we're going to do the last one. 2 times 5 is 10. And -7 times 4 is -28. It's a negative. And then we have 4 times 4 is 16. So that is your entire matrix when you multiply them together. So we are going to add all of these numbers together now. So 6 plus 3 plus 2 gives me 11. And 8 plus 3 plus 1 gives me 12. 10 plus 12 plus 4 gives me 26. 6 minus 7 plus 8 is 7. 8 minus 7 plus 4 is 5. 10 minus 28 plus 16 is -2. So we just multiplied a 2 by 3 matrix by a 3 by 3 matrix. And our solution is a 2 by 3 matrix. How do I know that? Well, I look at it, but I would know that before, because if you wanted to think about it this way, this and this is going to give me my solution of my matrix. So that's how that works. All right, so we just talked about, this is just explaining what I just did above, so I'm not going to read it to you. I told you on Friday that if I wanted to flip the order, so I have A times B is not equal to B times A, because if you think about it here, if I flip this, well, it would still work in this case, but it doesn't always work. So if I had a, let's say, if I had a 2 by 4 matrix and a, so that's matrix A, and I had a 4 by 3 matrix, and that's B, I could multiply it that way because they're the same. But if I flip the order, so that's B and that's now A, 2 and 3 are not the same number, so it doesn't work, but it still works in the beginning because they are the same number. The associative property applies because I can group them any way I would like. And this is supposed to be A, B is supposed to be in parentheses, not C, but it's right. You'll get the gist. And the zero matrix we talked about a little bit on Friday is still fine. You get the zero matrix. Your identity matrix, if it's a 2 by 2, and I want the eraser, that should not be there. If I wanted the identity matrix, if I wanted a 2 by 2 identity matrix, remember that we have ones on the diagonal, and you would get A, whatever A happened to be, because 1 times whatever is still that number. Distributive property in both ways works, so we're good to go there. Oops, didn't mean to do that. So scalar multiplication is different from regular multiplication because we just take one number and multiply it to every single thing in that matrix. So if I wanted to do a scalar multiplication of 2 to the matrix 3, 2, 4, and 5, I just pick numbers, it doesn't matter. So you would just take 2 times 3 would give me 6, 2 times 2 would give me 4, 2 times 4 would give me 8, and 2 times 5 would give me 10. So that would be what my matrix would be if I did a scalar. So you're just taking a constant and multiplying it by the matrix and every element in that matrix, rather than multiplying two actual matrices together. So if the order of matrix A is 3 by 2 and the order of matrix B is 2 by 4, then the order of matrix A times B will be, well, you're multiplying A times B. So 2 and 2 are the same. So your order of matrix AB is going to be the two outside numbers. So in this case, it's a 3 and a 4. So our answer is C. Helps if I can write on the page. Our answer is C, 3 by 4. All right, so now we are given some matrices. We have A, B, and C. Well, let's think about this. This A is a 2 by 1, right? A is a 2 by 1. And B is a 2 by 2. And C is a 1 by 2. I always find it easier just to think about that before we start anything else, because if we don't, then it gets complicated when we start multiplying things together. So if I wanted to multiply A times B, well, can I do that? A is a 2 by 1, and B is a 2 by 2. Well, 1 doesn't equal 2, as long as I'm concerned. So this one doesn't exist. So let's just write does not exist. You could write doesn't exist out, but D&E stands for does not exist. All right. So now if we want to do this, B, we want B times A. Well, B is a 2 by 2, and A is a 2 by 1. So I can do that. We're good to go there. Well, what is matrix B? Matrix B is 1, 0, 2, 4. And matrix A is -1 and 2. All right, so we are going to multiply them together. So remember what we did earlier. We are going to take the first row and multiply it by the column. So we're going to have 1 times -1 plus 0 times 2. And then we're going to have, so that's the first element. Remember, it's going to be a 2 by 1, so we're just going to have 2 rows in 1 column. So we only have, it's a small matrix in comparison to what we did earlier. And then I'm going to take 2 times -1 and add it to 4 times 2. So I get -1 times 1 plus 0 times 2 is just -1. And then 2 times -1 is -2 plus 8 is 6. So my matrix is -1, 6. And it is a 2 by 1 matrix. All right, now let's do C. We want to multiply C by A. So we are going to take, I can find color, the blue color I want. All right, C is a 1 by 2 matrix, and A is a 2 by 1 matrix. So I'm good to go, and I can multiply them together. So I'm going to get a 1 by 1 matrix this time, which is a little bit interesting. So we'll see how that turns out. So C is 1, 3, and we're going to multiply it by -1, 2. So we're going to just take this first row and multiply by this column and add the things together. So 1 times -1 plus 3 times 2. And that's the only element I'm going to have. So 1 times -1 is -1, and 3 times 2 is 6. So my 1 element matrix is 5. This is a 1 by 1 matrix. Really wish that'd stop popping up. That's all right. I'll figure it out later. That's a 1 by 1 matrix. All right, last one. So I have B times C. So B is a 2 by 1, and C is a 2 by 2. Well, once again, 1 never equals 2 as far as I'm concerned. So it does not exist. So don't go telling me that it exists if it doesn't. If you have any questions or still don't understand what you're doing, please come see me during office hours. This week they are Tuesday and Thursday. Hope you have figured this out a little bit at least, and try your homework.